We are going to continue our lesson by learning how to solve simultaneous equation by the use of elimination method. Now, if we should have, let's say, an equation, two equations, x minus 4y is equal to 9 as equation 1, and 2x minus 5y is equal to 7 as our equation 2. Now, the whole idea about elimination method is to try and make the variables the same. Let's say one of each variable the same. So assuming I have x and 2x, you ask yourself, what do I multiply with x to get 2x? So, okay, so if you are going to multiply 2 with x to get 2x, then it means you are going to multiply the whole of this equation by what? 2, which will give you 2x minus 8y is equal to 18. Equation 3. So with this and equation 2, which is 2x minus 5y is equal to 7 as our equation 2, when you subtract equation 2 from equation 3 or equation 3 from equation 2, you could see that 2x minus 2x will give you 0. So you eliminate one of the variables. Okay? That is the whole idea here. Make sure you are trying to use what? Let's say a multiplication of one of each variable to get what? Rid of one of them. So another example is if I should have 5x minus 5 plus 5x minus 7y equals to 20 as our first equation. And I have 3x minus or plus 9y is equal to 17 as our equation 2. Now assuming I want to eliminate x or y in this equation. Okay? Now you could see this is 5, this is 3. They don't have the same coefficient. This is also 7, this is 9. They also don't have the same coefficient. So what we are going to do is, I either give this equation or this coefficient of 3 to this, so that I'll multiply the whole of equation 1 by 3. And then when I come here to, I multiply the whole of equation 2 by 5. So that when I multiply this by 3, equation 1 times 3, I'll get 15, 21, and then 60. Then I multiply the whole of this equation by what? 5. So I get 5, 3, 15. So that when I subtract, this will go away. 5, 9, 45, 5 times 70, whatever you have it. Okay? So the whole idea is to eliminate one of the variables by just getting a number. When you multiply, you get the same coefficients, and then you subtract, and then one of them goes away. So let's pick an example and then we solve. Suppose we have a question. 1 over x plus 1 over y equals to 5 as our equation 1. 1 over x plus 1 over y is equal to 5. This is our equation 1. And then we have 1 over y minus 1 over x is equal to 1 as our equation 2. Okay? And we are asked to solve this simultaneously. Now you could see that we can use, let's say, the elimination method to solve this. Now, if I have 1 over x and minus 1 over x, this means that if I should add equation 1 and 2, I can eliminate x. Because from equation 2, okay, I can write equation 2 as minus 1 over x plus 1 over y is equal to 1. It's the same thing. This is equation 2. And then I bring my equation 1 down, which is 1 over x plus 1 over y equals to 5. This is my equation 1. Okay? Now, looking at equation 1 and equation 2, looking at equation 1 and equation 2, we realize that this is minus 1 over x, and this is positive 1 over x. They all have the same coefficient, 1 over x and 1 over x, but this is negative. So if I should add equation 1 to equation 2, it means I'll have minus 1 over x plus 1 over x, which will give me 0. So it means I'm going to eliminate what? X by adding equation 1 and equation 2. So let's add equation 1 and equation 2. Or if we like, we can even subtract equation 1 from equation 2 or equation 2 from equation 1 to also eliminate y. We can say 1 over y minus 1 over y is equal to 0. But let's start by eliminating x. Let's add equation 1 plus equation 2. So if we should add equation 1 plus equation 2, minus 1 over x plus 1 over x is 0. And we shall have 1 over y plus 1 over y. So if I have 1 over y plus 1 over y, you realize that our LCM is y. Y will go into y1 times 1, 1. Plus y will go into y1 times 1, 1. We shall have 2 over y. So this is going to give me 2 over y is equal to 1 plus 5 is also 6. Okay? So we are solving for y. So we multiply here by y, here by y. So I'll have 2 is equal to 6y. I divide here by 6 and here by 6. My y will be equal to 1 over 3. So y is equal to 1 over 3. Now since we have been able to find the value of y, we can put y equals to 1 over 3 into equation 1, 2, or 3, or equation 1 or 2 to get the corresponding value of x. So putting y equals to 1 over 3 into equation, let's say 1. So we have 1 over x plus 1 over y. Our y is 1 over 3 is equal to 5. Now let's solve for x. So this is 1 over x plus, this is 1 divided by 1 over 3 because this is our main division sign. This is 1 over y. So this is 1 divided by y. Okay? This is equal to 5. So this becomes 1 over x plus 1 times, we reciprocate, this becomes 3 over 1 is equal to 5. So this becomes 1 over x plus 3 is equal to 5. So 1 over x is equal to 5 minus 3. We take the 3 to the right hand side. We have 1 over x is equal to 2. So we are solving for x. We multiply here by x and here by x. 1 is equal to 2x. We divide here by 2, here by 2. Therefore, x is equal to half. So our values of x and y are, therefore, x is equal to half and y is equal to 1 over 3. So this will give us our corresponding values of x and y. Now let's move to our second question. Our second question says that solve simultaneously the equations 2p minus 3q equals to 4 and 3p plus 2q equals to 19. So we use elimination method to solve this. So we have 2p minus 3q equals to 4 and 3p plus 2q equals to 19. So this is our equation 1 and this is our equation 2. Now, when you watch through this equation, you realize that the coefficient of p is 2 and over here is 3. They are not the same. Over here is also negative 3 and 2. They are not the same. So what we have to do is we need to eliminate one of the variables. So we either multiply equation 1 by 3 to get 6 here and then equation 2 by 2 to also get 6 here. So the first thing we are going to do is multiply equation 1 by 3. We shall have the whole of equation 1 by 3. So 3, 2, 6p, 3, 3, 9q, 3, 4, 12. Equation 3. Now we are going to multiply equation 2 by 2. So equation 2 multiply equation 2 by 2. When we multiply equation 2 by 2, we shall have 6p plus 2 times 2q is 4q is equal to 2 times 19. We have 38. We call this equation 4. Now solving this, we realize that let's bring our equation 3 down, which is 6p minus 9q equals to 12. This is our equation 3. Now if we are supposed to solve this simultaneously, we realize that p has a coefficient of 6, which is positive. P also has a coefficient of 6, which is also positive. So for us to eliminate p, we can't add it. We have to what? Subtract equation 4 from 3 or 3 from 4. So we have equation 4 minus equation 3. So 6p minus 6p is 0. Then we have 4q minus 9q, which becomes 4q plus 9q, which will give us 13q equal to, then we have 38 minus 12. and 38 minus 12 will give us 26. We divide through by 13. We divide here by 13, here by 13. Our Q is equal to 2. Now, for us to get the value of P, we put Q equals to 2 into equation 1, or 2, or 3, or 4. So we have put Q equals to 2 into equation 1. So we have 2P minus 3, our Q is 2, is equal to 4. So 2P minus 6 is equal to 4. 2P is equal to 4 plus 6. 2P is equal to 10. Our P is equal to 5. So therefore, P is equal to 5 and Q is equal to 2. This is the solution to this simultaneous equation. Now let's move to substitution method. Now using the substitution method, it is best to make either P in this situation. Assuming I want to use substitution method to solve this equation, 2P minus 3Q equals to 4, my equation 1, and then 3P plus 2Q is equal to 19, equation 2. Now for you to use substitution method, you are going to pick one of the variables in either equation 1 or equation 2, and then you make one of the variables the subject of that equation. Okay? So suppose I pick equation 1, and I decide to make P the subject. So you write, make P the subject of equation 1. So making P the subject, you shall have 2P is equal to 4 plus 3Q. So P will be equal to 4 plus 3Q, all divided by 2. So you name this equation 3. Now, because we got this equation, okay, from equation 1, okay, we got this equation from equation 1, we can't put P equals to this into equation 1. Now we have to substitute this P equals to 4 plus 3Q over 2, which we got from equation 1, into equation 2. So we move to equation 2, we put P equals to 4 plus 3Q all over 2 into equation 2. So doing that, we shall have, so putting P equals to 4 plus 3Q over 2 into equation 2, we shall have 3 into, our P is now 4 plus 3Q divided by 2. Then we have plus 2Q equals to 19. So we put P equals to 4 plus 3Q over 2. So wherever we see P in equation 2, we put 4 plus 3Q over 2. So we have 3P plus 2Q equals to 19. So we go ahead and then we solve for Q. So looking at this, we can decide to multiply 3 times this, 3 times this. So we have 3 times 4, 12. 3 times 3, we have 9Q. We have 9Q all over 2 plus 2Q is equal to 19. So since 2 is our LCM, we are going to multiply through the whole of the equation by 2. So multiply here by 2, here by 2, and here by 2, because there are 3 terms. First term, second term, and then the third term. So we shall have 12 plus 9Q plus 4Q is equal to 2 times 19, we have 38. So 9Q plus 4Q is 13Q. Okay, let's group like terms. We shall have 9Q plus 4Q is equal to 38 minus 12. So we have 13Q is equal to 38 minus 12 will give us 26. So we divide here by 13, here by 13. Our Q is equal to 2, which is the same answer we had for the first one. So if we want P, we shall put Q equals to 2 into equation 3. Let me make this equation 3. This is our equation 3, which we have P to be equal to this. P has already been made a subject, so we just put it inside to get the value of Q. So we have P is equal to 4 plus 3 times our Q is 2 all over 2. So therefore our P becomes 4 plus 3, 2, 6 over 2, which becomes 10 over 2, which is equal to 5. So we could say that our P is equal to 5, and then our Q equals to 2. So this is the substitution method. The substitution just involves what? Change of subject. Making one variable the subject, and then you put it into the other equation, and then you find the corresponding values of x and y. Now let's solve some more examples under substitution method. The sum of two numbers is 8, and their product is negative 33. Find the numbers. So we are told that the sum of two numbers is 8, and their product is minus 33. Now we don't know the numbers, so let's name the numbers x and y. So let the missing numbers be x and y respectively. Now we are saying that the sum is 8, so x plus y is equal to 8. So we call this equation 1. And their product is minus 33. So their product xy is equal to minus 33. We call this equation 2. Now we are supposed to find the values of x and y. This is addition. This is multiplication. There is no way we can use elimination method here, because the equation 2 is not separated by addition or subtraction. They are multiplying. So the best method to use here is substitution method. So looking at equation 1, from equation 1, we can say that x is equal to 8 minus y. We could say that from equation 1, when we make x the subject, x is equal to 8 minus y. We call this equation, let's say 3. So we put x equals to 8 minus y into equation 2. We can't put it back into equation 1 because that is where it is coming from. So we put this into equation 2. So wherever we see x, we put 8 minus y. So we shall have x is what? 8 minus y multiplying y to be equal to minus 33. So we solve for y. So we multiply. Y times 8 is 8y. Minus y times y is minus y squared. Is equal to minus 33. So this will give us, we shall have, let's take everything to the right. We shall have y squared minus 8y minus 33 is equal to 0. I took this to the right and this to the right. Okay? So we have y squared minus 8y minus 33 equals to 0. So this is a quadratic equation. Okay? And quadratic equation, which is of the form ax squared plus bx plus c, we know what we do. We multiply, we look for the coefficient of y, which is 1, multiply it with this, look for two factors of, let's say, minus 33. When we add, we get minus 8, and then when we multiply, we get minus 33. So looking at this, 1 times 33 is 33. So I think 3 times 11 will give us 33, right? So we can use minus 11 and 3. Because minus 11 times 3 will give us minus 33. And minus 11 plus 3 will give us minus 8. So we shall have y squared minus 11y plus 3y minus 33 is equal to 0. So we solve for y. What is common here? We have y. We shall have y minus 11. Plus 3 out, we shall have y minus 11 equal to 0. So we can say either we have y minus 11, which is the one in the bracket, and then y plus 3 to be equal to 0. So we say either y minus 11 is equal to 0, y is equal to 11, or y plus 3 is equal to 0, y is equal to negative 3. Now, since we are having two values of y, this means that we can also have two values of x. So we are going to put each value of x or each value of y into equation 3 to get a corresponding value of what? X. So putting y equals to 11 into equation 2, okay? Into equation 3, sorry. Putting y equals to 11 into equation 3. We shall have x is equal to 8 minus y. Our y is 11. So x will be equal to 8 minus 11 is minus 3. Then putting y equals to negative 3 into equation 3 again. we shall have x is equal to 8 minus y is what? Negative 3 minus 3. X will be equal to 8 plus 3. X is equal to 11. So therefore, when x is equal to 11, y is equal to negative 3. And when x is equal to negative 3, y is equal to 11. This is the solution. Because when x is negative 3, we have y to be... When x is 11, y is negative 3. And when x is negative 3, y is 11. So this is our corresponding values of x and y.